Hey guys, welcome back to yet another video. In this video, we'll be trying to solve the 167th Leetcode problem, that is 2 sum 2. So now in 2 sum 2, the input array that they give, it will be sorted, alright? So it will be a sorted array. So given an array of integers that is already sorted in ascending order, find two numbers such that they add up to a specific target number. The function 2sum should return indices of the two numbers such that they add up to the target, where index 1 must be less than index 2. Okay, so now let me make things like a bit more simpler for you guys. So now in this array 2, 7, 11, 15, we can see that the target is 9. So as we can see that the elements of the 0th index and the first index, so like when we add them together, we'll get 9, right? Because 7 plus 2 is 9. So like since it's the 0th index, we are like supposed to output 0 plus 1, and the first index, like we are supposed to output 1 plus 1. So like the answer is like supposed to come as 1 comma 2, as you can see here. Okay, so yeah, let's see how we can solve this. Let's move on to the whiteboard. Okay, so now this is our array, all right, 2, 7, 11, 15. Now this is a sorted array, okay, and our target given right here, it is 9, right? It's 9. Okay, so now we'll be having a left pointer and a right pointer in the array. So the left pointer will be at the 0th index when we begin, and the right pointer will be at the last index. Okay, now we'll have a variable called s, okay, which will be the addition of the elements. Okay, so now let's say the array is nums. Okay, now s will be equal to nums of left plus nums of right. Okay, so in this case, like by default, it will be equal to 2 plus 15, that is 17. Okay, so now like the first thing we should check is if s is equal to the target or not. Now of course 9 is not equal to 17. Okay, then we will check if s is bigger than or smaller than the target number. So in this case 17 is bigger than 9. So what we do is we will shift the right pointer one step back. So now if you guys notice a pattern here, it is that when the right pointer keeps on going inside, the sum also keeps on like becoming less. Whereas if you move the left pointer more and more up, the sum also becomes more. Alright? Okay. So now the right pointer will be at 11 and the left pointer will be at 2. So now we'll check their sum. 11 plus 2 will give us 13. Again, we know that 13 is bigger than 9. So what should we do? Now to make the sum small, we are supposed to shift the right pointer more inward, right? So now the right pointer will go from 11 to 7. Now when we'll add these two, we will get 9 as the answer, which is the output we wanted. Okay, yeah. So now that's how you solve this problem. Let's code this whole solution out, like it's a relatively easy problem. And yeah, okay, so now we'll be having two pointers. Left will be equal to 0 and right will be equal to the length of nums, or it's actually numbers, minus 1. Now while left is less than right, so now the main reason we're doing this is we don't want left and right to overlap, okay, because the same number can't come more than once. Now s will be equal to numbers left plus numbers right. Okay, simple enough. If s is equal to target, return, we need to return a list of left plus 1 comma right plus 1, right? Because even in this case the indexes of 2 and 7 are 0 and 1, they want the answer as 1 comma 2, right? Because it's the first element and the second element. So now we'll just be adding 1 to both left and right. Now if s is less than target, So now if s is less than the target, we want the sum to become more. So now if we want the sum to become more, we will just increment left. Add 1 to left, so it moves more up. Now else, the only other case is if the sum is too much, and when we want the sum to become less, we will just do right -1. Okay, now that should be it. Now at the okay, now that's it, right? Yeah, this should be it. Let's run the code and see if it works. I'm praying there are no errors. Oh, it works. Let's submit. And there you go. Oh, it's unusually slow. Let me just run this again and see if I can get a better time. Hopefully I get somewhere in like 40 milliseconds. Okay, 44, good enough. So now that's how you solve this problem. Hopefully you guys got the idea. If you have any doubts, do leave them in the comment section down below. And that's it for this video, and I'll see you in the next one. Bye.